meetings before, you know.
All right, so we are live, and let me just quickly tweet that we are live. Too many browser windows open here, which makes it kind of challenging. Because I have to tweet from 2 accounts or tweet from one and retweet from the other, it's all easy.
You gotta streamline that.
We should write a tool for that. If only we could write software.
Is it .NET in your account, or what are the two accounts?
Yes. All right. So today we want to focus on 2 things. Let me actually share the screen. That's probably helpful. Wrong button. Screen 2. 1. Some preferences. Which one we start with?
That one.
That one.
Already up there.
All right, that sounds good. So then I think it would be good if one of you guys could give an overview of where's the other guy? There. What we actually did there and what the goals are, and then we should probably look at the sample code first before we actually look at the API. So let me bring this guy back up.
So basically, what we've done is we have built an API at top of the new metadata reader. To consume all the metadata out from an assembly, to have an object model API of that assembly, and with the capability of dumping it to a file that you can run through ILDASM and get a running assembly with that API.
Think of it like this in ILDASM, but a library that can do whatever ILDASM does. Using this library, eventually we could do more things, like maybe there's a UI or do some other fun stuff with it.
Does it give you like the IL as instruction points, or like as in an enum, or like how does it work?
So basically, you access the assembly through the main assembly object.
Okay.
And there you can get the types, and then for each type you can get the methods. And the methods will have instruction objects that have the token and the actual value that the instruction receives as an argument. And you have a dump method for every instruction that will give you the string of how the instruction is represented with that token and that argument that receives.
You get it as objects, and then you can do whatever you want with it. We also have a way to dump it to a string.
So this is basically the convenience method where you literally just get back the entire string representation of the entire type, but you can also walk individual methods and method bodies to actually get just the subset.
Yeah,
Yes.
If you're interested in doing patterns, like searching for specific patterns of your instructions, you can do that.
And all of the methods, all of the objects have its own dump method where you can get the string of that object representation.
You can get, like, you can call dump at any level in the tree, and then you can get just the subtree as a string.
I see. We're planning to replace ILDASM with that tool, or?
There's no immediate plans to do that, but this is a stepping stone towards that.
Cool.
Having it as a library, and you can build on top of it, as I said, UIs or things.
And today, currently, ILDASM is native, correct?
Yes.
So this would, having the library, moving that to manage would
Be cross-plat.
make us cross-plat.
That was another goal that we had. That's why we wanted to do it on top of the existing metadata reader, which is already managed. So we can run it everywhere.
And the other nice thing is, from a Roslyn perspective, we use ILDASM in our unit test all the time, but we have to shell out to a process. We have to dump things on disk. It's expensive in terms of PERT, and it's somewhat inconvenient because cross-plat we're kind of toast. Having it as a library would be hugely convenient for us because we could avoid shelling out and be cross-plat. It would just work. It'd be critical.
So out of curiosity, like how would you use the library in the unit tests? Like what would you be looking at?
So in unit for ILDASM, very often we compile things and we just want to know, like, did we emit the right opcodes? So there are very specific things in C#, for instance, compound operators like plus equals, minus equals. It requires a very specific codegen from us to get correct. We can do kind of, write a program, make sure it outputs the right thing, but it's much better to just say, hey, look, we should be emitting this IL, and if we change this IL, that's a problem, even if we still get the same output. So those are the typical operations we use it for.
And as part of his project, we also implemented the method body parsing, which was not part of the metadata even. So you couldn't even haven't gotten the information right now from the metadata redirects. You would have gotten just a blob for all the byte stream, and now we're processing that into nicely strongly typed objects that you can look at.
Do you require it to be compiled, or can you also just decompile a byte array?
I don't understand what you mean.
So, like, I think in Roslyn, like, do you emit the assembly to disk, or do you actually have it in memory?
Today, to use the tool, we have to emit to disk. It would.
Oh, good point. Yeah.
So if it would be, I assume this API could run over a byte array, essentially something that was loaded in memory versus disk. If not, that would be like, please add.
Yeah, I think we have. You can speak to that. I think there is a stream. There's a constructor that takes a stream.
Yeah, so we have both constructors on the ILDASM. You can give it a path that points to the PE file, or you can give it a stream.
For us, right, Latin American, we emit the IL to a stream anyway. Yeah,
Yes.
yeah, we emit the IL to a stream anyway in the compiler, so that would be really easy for us to get that.
But that stream, I think, requires the entire assembly, correct?
Yeah, but we free the compiler is emitting. We're emitting.
Yeah.
We commonly emit in the unit test to a stream object, and then write the stream out the disk or pass some other function. We already have the full thing in memory several times.
Would it make sense to have like at the method body thing, just give it a, as you said, a byte array or just some random like low level things for the method bodies? Would it help Roslyn?
I don't think. I mean, as long as it takes a stream, if you have a byte array, creating a stream over byte array is just new memory stream. So
I think what he's asking is, like, if you just have the method body, not the entire assembly.
oh yeah, we definitely would like to get the method body back from the API.
You can get that, but the other way around. You pass it a byte array and it gives you back instructions. Would you?
Where you don't have a whole assembly.
Where you don't have exactly.
But you will have references to tokens.
Yeah,
how
you
do
have to have
resolve?
tokens to be able to do that.
That's fair.
Yeah, currently what happens is we don't want to touch the disk. So what happens if we emit assembly, we run assembly that happens in memory, but then it's kind of lost because we cannot get the IL back from that. So we have a bunch of hooks, which are specific to test, where you set the flag saying like, don't dump the method bodies, put them in a hash table on the side, because after running this piece of code, we will also examine the quality of the code gen.
Okay.
So like the ++, there are like so many ways to emit ++. Some ways are better than others. We want to see that. So a lot of this machinery would be unnecessary if we could just read that assembly from the stream.
From memory.
Yeah, but we're emitting the whole thing.
Yeah, and I think what you said was right. The fact that you need to resolve tokens.
I need to resolve all the tokens from the metadata.
Yes.
So that one-
Currently, we have hooks which keep the method bodies and keep the metadata and everything, because when we will start visualizing IL, we will need the tokens and their language specifics. So that there are methods there which take like 5 generic type parameters and a bunch of lambdas just to support this language independent visualization of tokens. It's just convoluted and it's just for testing. And you're still not 100% sure this is exactly as it would have been emitted, because there is a lot of special stuff going on.
The machinery to keep all that information.
There's always a degree of a doubt that we might be kind of interfering with the process because it's too much. It's not exactly we're reading bytes we've just emitted. We're reading some intermediate state.
So I understand that the metadata reader is very low level, and when we wrote that, we thought, it's very useful for Roslyn and maybe a couple other things, but someone would need to write something on top of it to have an easily consumable library just to do general like reflection stuff. So does this library fit that, or what pieces of that does this library fit?
I don't think it's supposed to be a full-on replacement of reflection.
Well, not reflection. I mean, reflection where you don't want to.
I think you're essentially saying that the metadata reader is very low. It just gives a very low reading the metadata, just raw tokes, things like that, you're saying basically something that Roslyn's an extremely high level view of the metadata, and CCI is kind of in the middle. You're basically saying something more on the CCI layer.
Yeah, I'm just wondering how it fits in there, and reflection is not really appropriate for a lot of scenarios where you want to do something in the build process.
I think reflection does kind of about a type system. It's a simple table, for lack of a better word. This seems to be more like the low-level instructions, just like a structured view of the metadata. It doesn't naively seem to be like a symbol table replacement.
I think of it as a better two-stream in many cases. Versus if you look at metadata reader itself, it doesn't have an object model, right? So basically,
Exactly.
you cannot say, give me all the types and then walk from the types easily to the members, and then even signatures are hard in metadata reader.
Exactly.
Like we are adding that info. Like I think there's a proposal to actually add at least some sort of object model for the signatures, but it's still not a full-blown object model. Like I did a prototype at some point to create an object model over it, but it's not quite that easy because there's lots of policy that goes into that. Right? In a perfect world, you would match what CCI does, which is you would have a notion of a resolved type and unresolved type, or a type reference, so to speak. But that in metadata there are certain areas where that's not well defined if you can resolve types, like enums and attributes and stuff like that, or constructor arguments of attributes. You kind of have to resolve in some cases to actually get that information reliably. But we don't have that. I mean, it was always on the list of things you would like to do. But
Yeah, I'm wondering how does this fit? Does that give us?
I think it's basically just a better two-string in many places. Yeah. It's not an object model. Well,
it sounds like it's partially an object model because you can walk the tree of,
You can, to a certain extent, yeah. I mean, probably we should look at the APIs at this point, but actually, let me share the screen again. So what should we look at first?
So in ILDASM library, we can find like the main object that I've got right now. So ILDASM is how you construct the main object that contains the assembly. And then if we go to ILDASM assembly.
So do we want to do high-level comments about the names now, or go on the individual APIs? Because I'd say that the kind of thing is the namespace in general, the library suffix, like everything's a library. And if we are thinking about longer term, where we're both going to have assemblers and disassemblers, would it make sense to put them under a shared namespace like system.il.disassembly, system.il assembly, or something of that nature?
I don't think we've thought about that as much right now, but I think it'd be a good thing. Just, I don't know, maybe, I think system.il.disassembly would be a good start, and then we can continue to that. I don't know if we have anything else in the system.il and any other.
Yeah, I'm horrible at naming, so I always hesitate to say anything about names, but I'm good at criticizing other people, so I'm fantastic at that.
Something that I don't like that name either, but
He's already tried to improve on it.
The ILDASM class, is that just a factory for ILDASM assembly?
Yes.
Okay.
So that's where you pass the file path or the stream to build all the assembly.
Okay. Do we have that pattern for factories in other places? Because I'm most used to factories being static methods or something like that.
Well, you just build it out of a constructor, not out of a static method, like you meaning of like a create method, right?
Sure.
Yeah,
So
usually
what I'm
we do ILDASM.create,
Okay.
and that would return as assembly.
Okay. So yeah, all the pattern here is made based on the constructors.
Sure.
So
Yes.
it is not as a factory.
It acts as a factory,
Yeah.
right?
Yeah.
Yeah. I just don't know that we have that pattern for factories.
And I think that if you want to go that route, you could just move the constructors of the ILDASM, like the constructors on ILDASM, make them create a static create method on the ILDASM assembly, and then get rid of the ILDASM class altogether. That's how we could just, if we want to go that route.
Is there any reason to go with constructors and returning the property?
Does the ILDASM object have anything else on it?
No, just the assembly.
And also, is this really an assembly, or is this not the module in general?
What's that?
Is that actually an assembly, or is it a module in general?
Is the actual assembly.
So you cannot actually open individual modules. You have to basically open. Do you resolve other module references?
Not yet, but it's on the scope to be able to access the model reference.
Because it seems like you should probably just mirror what, does the metadata reader? Does anybody know, does the metadata reader actually have modules, or did we flatten that away?
I was looking at that today and yesterday to try to come up with that so I could show it on Apex, and I didn't find a way yet to access the model references from the metadata reader.
I see.
Pretty sure that the metadata reader.
Just one we had that.
Because I was looking at that code the other day where we were looking.
I saw that it resolves handles for model references and model definitions, but I was not able to get the handle collection for them yesterday or today.
I'm kind of assuming that we probably, in general, we should probably, I don't know whether it's true or not, but if the MD reader exposes modules, so should library. Because if it's really conceptually low level, it should probably not even resolve assembly refs. It should literally just give you similar what ILDASM on the command line does. If you just dump an assembly, and that thing is actually not an assembly but a net module, it would give you that information. And if you would dump the main assembly, it would probably have a dot module section somewhere, and there's points to the other module. I think we should just mirror that. So if that's the case, I would not call this an assembly because it may just be a module.
You just call that module.
Yeah, I think that if that's, I don't know what the nomenclature is that we use in metadata reader, we should just match that.
Okay.
So that's all I'm saying.
Would it make sense to just remove ILDASM prefix everywhere, just make it the root namespace and that's it?
That's the other thing that I thought.
And it'll make it shorter. You are inside the ILDASM namespace anyway.
Names, type names should still be in their namespace. Because, for instance, we did assembly. It would assembly is too general. It conflicts.
But it's the same as you would say reflection type, reflection something, reflection that. It's inside system reflection anyways. So.
No, I think that's a good point. Honestly, these types here in instructions, I think are fine if you remove the ILDASM prefix because they're already specific enough.
It also declares the something instruction, so it's kind of.
For these guys here, we had the same discussion with the metadata reader, right? Because then, it already has very similar names of metadata reader. So the question is, if we were to build an object model, we would immediately collide names, right? And then the question is, do I use the object model and the metadata reader, and I have now two types called assembly, and two types called field, and two types called local. And when you start to decompile, you have yet another type called assembly, yet another type called field.
Yeah, that's right. For example, in the method definition and the type definition and all that, in the metadata reader, they're just called like that.
Mm-hmm.
So since this uses the metadata reader, I could get conflicts on that.
Yeah.
So you could use an alias to alias the namespace and call it something else, but then again, it's a lot more work and not necessarily easy to figure out.
If we have to do that in this code base, that's kind of fine. It's a question about if people are using this together with the other types, will they have to use aliases too much?
And then the other part was, should we rename the prefix? Should we?
What is the assembly references return? Is that a metadata reader object? What is that?
Yeah, that's a metadata reader object. But I think I should build a ILDASM object that describes the assembly reference more on a higher level. But I haven't gotten there yet, so I just expose it like that so that you can see that we're going to have that property.
Or should we investigate if we can remove it without creating conflicts?
Well, I mean,
We can't use assembly if we put in system reflection metadata ILDASM because then it will conflict with system reflection assembly.
I know. That's why I was asking.
Well, are we going to rename it to module? Is there a system reflection module?
That's fine. That's one type, right? Like,
yeah,
what about the others?
method
Like,
definition, type definition.
and we can fake up names or make up names, but I don't know if it's really worth it.
So the other question that I have is this object model that you have here. What does it, like, how would that fit into a world where we actually have an object model?
Was that?
So imagine you would actually build an object model over ILDASM, right? Similar to CCI.
Yeah.
How would that object model relate to this one here?
Couldn't we just expand on this one?
And this could be an object model.
And you're essentially, so your object model doesn't have representation for, or does it actually? Oh, you have it for type, right? I see. So your type representation is essentially a string, more or less?
No, yes, sorry. So so there's type definition in the first, there, so it's type definition. So that's what a type definitions got.
But how do you represent, let's say, types and signatures? Like, let's say,
With the other one, just as a string.
yes.
So it's got a name, and if it is class type or value type.
So a byte array would basically literally be represented where the name is byte brackets, basically whatever the IL representation is.
Yeah. So
Is there ever a mapping between type and type definition?
no, how I get the type is with the signature decoder provided by the metadata reader. So the signature decoder provided by the metadata reader is generic, and that's what I produce on my type provider. So I create ILDASM type objects.
But that's like when those get created when you're like reading the individual instructions.
Yes.
And so if I have an instruction that refers to a type in my own assembly, then then I'm reflecting over parsing or whatever, then I'll have the object model, which will be assembly, and I'll have some types, which will be type definitions. And then I go into their methods, and I'm decoding the methods, and then they might have.
Reference back to the type that
It'll be an ILDASM type, right? Not a type definition. And they're in this library. There's no link between those, right?
No.
Okay.
You're basically asking if I can go from a call from an instruction that references a type to the actual type defined.
Yeah.
You would need to do binding.
Yeah.
The resolution and all this stuff. Yeah. I mean, and that might fail.
Yes.
Well, it might be outside the assembly, so.
Yeah, this type is more like a type ref, right, in the general case, or a constructed type, if you will, which is very different from the type definition. So, I mean, everything. So, what's the difference between the structs and then the classes? I mean, you have a hierarchy where some things resolve from ILDASM object and some things are just structs, right?
Yes.
What was how do you decide which one to use?
So the higher level objects that are inherited from ILDASM objects, so just type definition, ILDASM method, ILDASM assembly thing, which they have which they share names and stuff like that, like namespace, so that you just call the get cached value method in ILDASM object, so that they don't have repeated values in them. And for example, ILDASM field, ILDASM local, and ILDASM parameter, which are cached on those objects are struct, since they are using innumerables, so they are cleaned up faster.
So, in a sense, everything that inherits from ILDASM object is essentially just having a cache built into it, right? To a certain extent. And I guess you have to reference the metadata reader itself.
Yes, so you get the value from the metadata reader. So that's what get cached value does.
Makes sense.
Protected, it's only to share the implementation with its derived classes. Is there a reason that you wouldn't want to take the cache and compose it into those types that need it rather than put it in the inheritance hierarchy?
What do you mean?
So the ILDASM object class only has a protected method, so it's only there to share the implementation of the cache, I guess, with its inheritance hierarchy. And so, is there a reason that you couldn't take the implementation of the cache and put it in its own helper type that was composed into the descendants rather than put into the hierarchy?
This is a helper method, right? It's non-virtual, so it's in the hierarchy.
I don't think there's any particular reason, just maybe convenience, because you don't have to go through another. Like, it's easy to write, easy to write.
Yeah, it is odd though to have a base class with nothing virtual or non.
Yeah.
You know,
And
like you have the ILDASM object, but would you ever take one of those? Like, what would you do with it?
like when you put it in the inheritance hierarchy, it's also really visible to people who are interacting with the API. And so, if there's
Like imagine alternative design. Imagine you have an internal object called, let's say, ILDASM cache.
No.
And that basically has a reference to the metadata reader, or some object that basically holds onto the state. And you pass that essentially as you're walking the object model, you just pass it to the things you hand out.
Yeah.
And so it completely disappears from the API service. Just whatever bookkeeping you have to do, that's part of the internal implementation. Because the other thing is once you technically this is not something you would first of all, you can't call it because you can't derive from this line, right? So as soon as you make this thing,
Sorry, can you say that again?
you cannot call this method up on the outside.
Oh, from yes, unless you derive, sorry.
Yeah, you can't derive because the constructor is not public, right? So if you make this guy internal, then you're left with basically no APIs of the type whatsoever. And at that point, it becomes it bleeds into the consumer of something that you just want to do internal code sharing. At which point,
it's just that if there's not a reason to put it in the hierarchy,
Yeah.
I strongly favor composition.
So I got here late, sorry, and I see some things just above this I want to comment on. Stop me if you already covered it. So, oh, what's that? Oh, we went straight to ILDASM object. Yes. Perfect. I'd like to look at these classes first, right?
yeah. So the one thing we already said is we need to think about the names because there's some general you probably want to remove the ILDASM prefix, right? But then the question is, that probably works out here, right? For these kind of things which are pretty specific to ILDASM. These things here are likely to collide one way or the other, right? You would have to come up with some smart naming that is not terrible and also doesn't collide with the reader, nor reflection, nor any object model they would ever provide on top of that, right? So that's
Basically, instead of calling it ILDASM assembly, we would call it assembly or module if we were to go that route. But well, we might collide, which is
Maybe just IL. Does the DASM add much?
Give it a DASM, and then you can use it for.
I like
That's
that.
not a bad idea,
I
actually.
like that.
yeah.
Just be IL assembly.
Yeah.
I mean, are we gonna do ASM and are we gonna reuse these types?
That would make sense.
That would give another reason.
Yeah,
I would
we could,
imagine
yeah.
it's pretty reusable, right?
Yep.
Although I imagine it needs solid mutable here. TBD.
Well, yeah, we should figure out what the instructions in the writer look like to see whether or not the types are defined
We
in a
have
way that they
time.
can be used by the.
We have plenty of time to
Yeah.
sort of reconcile the writer with and update the. Like for now, it's system. It's the reader, but I still think even if it's just the reader, we need to put DASM everywhere. It's getting long.
Yeah, sure. And it's ILDASM is also it's unique enough that it won't collide, and general enough that you can reuse it for reader writing. So, good name.
Also, like you have an object model, but it's very much tied to the semantics you need in IL, the language, right? So like flags, I assume, for example, would give you whatever the IL textual representation of the flags are, right? It doesn't give you just the number to string, I assume. Right. So like this is not a general purpose object model, right? It's very much essentially an object model for the textual pieces of information that make up an IL document, if you will, right?
So on that, actually, I was interested. Could you jump to like ILDASM branch instruction?
ILDASM branch instruction. This one.
Yeah. So yeah, that has the dump, and then so each of these instructions has the textual representation of the IL built into it.
Yeah, and they have the opcode and the token and the value representation of that token.
Okay. I was wondering if you'd considered doing like a visitor pattern to support either different methods of writing these out, or talking about the Roslyn test scenario. If you were able to construct yourself a visitor that could go through these IL instructions instead of having to walk the objects, that might be something that would be useful to you guys.
Maybe.
We already have something similar for PDB. Actually, it would be nice to add PDB functionality to this eventually, if that's possible. Because currently we have two modes of visualization. One visualizes IL, another visualizes debug information. I think there is a sort of merge mode where it shows IL and puts little thingies there saying sequence point here, sequence point there. So in addition to looking at IL, sometimes you want to see the debug information there as well. And if it's sort of merged, it would be easier, because currently debug information just spits a bunch of XML. We use some public PDB to XML.
So that's something in mind that looks similar to the decompiler view, where you have the source information dispersed with the assembly, except that you want to see IL instead of the native assembly, I guess, right? Yeah.
So in PDB scenario, our current scenario is you produce the assembly, and then you say, here is the assembly, give me method class1 dot class2 dot method 1. And then we have a visitor which goes through that object model provided by PDB to XML and finds the method. And so we already have visitors which are extracting only the method that we need, because that's how PDB to XML works.
Yeah.
On the IL visualization, since it's completely custom, it works the other way. It basically dumps all the methods into a hash table halfway through and keeps them around. And then we just fetch it based on the name. But it doesn't need to be like that. It would be fine to say, like, here's the class1.class2.method, give me IL, or give me PDB, or give me both.
I'm just thinking, because the class, classes that are under the instructions are the IL instructions, I guess, and they're unlikely to change. So the visitor could be suited for that.
It would be okay for us to implement visitors on top of this.
Okay.
I mean, it would be nicer if they were already there.
Okay.
How would you visit, like, the method body has like a flat list of instructions, right? What would you do? Like, you would just visit each of the instructions to do something custom to it, other than dumping it to string? That's what you would...
Currently, we just dump method bodies into readable text.
I see. And this would already, like each instruction would have, right now has a dump method. You think of adding like a visit or accept method to allow...
After that, we just compare.
Or you don't even care.
Yeah, it is just baseline of the test.
I see.
right now, the structure of this code right now is conflating the idea of visiting and dumping.
Yep.
And there are certain things which, the default dump of ILDASM I find to be like somewhat annoying, personal preference. I hate the fact that it puts certain labels on the left-hand side. It's nice to have sometimes more concise output, but if you have a visitor, then you have the chance of customizing it. If you encode it into the types, then you kind of locked yourself into one pattern. I think in general you need to have the dumper to get the things there, but
Yeah, I think that's a good feedback. We could probably start having generalize the dump method into
Yeah.
provide a
text dumper.
But our current test routines, they stop at the method body, so they just produce it as a string, and we compare them.
I see.
So like you change a little something, and one instruction changes,
You
you
still
see an ugly diff, but
You still see it.
you still see it. It does have some. It tries to dump that in a pretty way. So like if you have exception handling, it put curly braces and all this.
Okay.
But that's mostly for convenience of reading. We don't traverse or visit those exception scopes in many ways. It's just text.
Yeah, actually, that comparing sounds like another reason that it would be nice to have different implementations of writers that you could plug in as a visitor, so that you could have one that was nice and could change and could format nicely, and then you could have one that was concise and didn't change and was designed to compare to persisted test data.
Currently, there's nothing structured there. It's just a bunch of instructional visualization.
Yeah.
Once you make a diff, you see it a lot of red.
But currently, the way that you get it is you get an immutable or an unmutable array of instructions, and each instruction has its own type. And then you can, you don't have to call the dump method on it. You could just do a linear scan of it and then do whatever you feel about. Like to me, the visitor pattern is more around trees, and there's not really a tree for the method. I understand for the method definition and types and all that makes sense. But
Well, it depends on how you see the visitor, right? I mean, if you have a flat list of things, the visitor, what it buys you also is you don't have to handle the types, right? If you have a uniform, let's say you have an immutable array of instruction, right? Like the caller would then have to do a switch over the kind and then say, cast it to this, cast it to that, cast it to that. If you have a visitor, what you do is you just basically call visit, and then that guy will call the corresponding method. So if you just specialized methods, and then you just override that one method, you handle that type, and then you move on. I mean, it kind of does that, but
Just to play a little bit of a different angle here, like IL, by its very nature is simple, and do you even need different classes in cast?
Yeah.
Like, can it be represented with, switching over the opcode and getting the certain values out of it? And I know that I would be curious to know, how much time we're spending, are we over designing, maybe if in the case where really something that you can really just switch over and sort of, you could be potentially an instruction, honestly, I would expect it a method body representation, that compressed IL is really slightly annoying, but I can imagine something that's basically just a contiguous block that's pretty easy to walk. And I know we're going into patterns of visitors and so forth, so it's not really friendly to those sorts of designs. But I think I would really be curious to see sort of the code samples of what we need to write and whether we really need this hierarchy at all.
for the instructions, you mean?
Yeah, because I worry about it. I know when CCI does something like this, and we end up in .NET Native spending a lot of time with these. But I don't know. In this case, if the goal is always to dump out text and stuff, and you're doing a bunch of I/O and whatnot, or you're debugging, it depends. If the throughput here is really important or not. But certainly it's something that I would just like to make sure that we're thinking about it.
So ask your question about, does the object model give us anything over just an enum? Do any of the classes in the instructions namespace have different fields or properties than other classes in there? So I mean, they're
They do, but it's possible to represent it in various ways. I'm sure some of the things are properties of the instructions, which you can just have a table on the side and say index into it by the opcode, and you can get some of its properties, and then some of them have different values and stuff.
Sure. So it sounds harder though.
It's
The-
harder,
the other
but it
option-
might be worth it. I'm not suggesting that it has to be done that way. I just think whenever I think it's something to consider because I know that we've been in situations where, like, this is not your like typical tree, It's like really kind of like you want to visit it because
I don't think
because it has a
visitor pattern
complex
is just for
structure. Where
tree.
it's a very kind of a fine-
The visitor pattern also
Can we say
uses
that,
like
guys,
compile
for the
time
instructions?
guarantees that you've gone ahead and you've implemented all of the what would otherwise be switch statements and runtime casts and everything.
So
That
I
may-
think the reason why we went to this current approach was so that it's easier for the consumers to see what they are. Because I mean, another approach we could consider was having just one IL instruction class that had double operand, single operand, all of the operands, and it would be the callers for us to say, hey, switch on the type of the opcode and see what kind of operand do I want to get. But we want it to be a little more.
Do we have like two layers here? Lower layer that basically is just a simple parser, non-allocating, and then distinct layers on top of it, or not?
Underneath this is just we give you bytes. So there's something probably a missing step here,
So you
right?
see, I would kind of wish we had like very low level library that just is very efficient parser, correct? Non-allocating, no string, nothing. Just kind of interprets the byte stream for you.
This can be efficient. I mean, you just add some caching. IL is very repetitive. So, like,
Well, yeah, but
you'll
it's
be
like
loading,
bunch of
you'll be loading argument 1, argument 2, argument 3, maybe argument 4 sometimes. So you'll have 4 instances
Sure.
of the load argument. You put them in a little table and you have both an object model and efficient allocation.
But I mean, all
But
of
we-
these things are now classes, right? So if I walk the instructions of a normal method, now every instruction essentially allocates an object,
Yeah.
and all it does is
You can reuse the instructions because they're
Yes.
immutable.
Yeah,
There are a lot of
immutable.
repetition.
Yeah.
But you do get indirections, right? You still get you still bounce around. But I don't know.
Right. So like many of these collections are exposed as enumerable of something, correct?
Switches.
Well, when you
Not common.
still they are not common, but every time you call enumerator, get enumerator, you have an allocation and this and that. So that doesn't look to me like a low-level API for kind of advanced scenarios. Yet parsing IL is an advanced scenario. It's kind of
Probably not that hard to insert a level in between that's just a forward only kind of like a cursor over the bytes that says, okay, currently you have this opcode and you have these, and you can do it without allocating, and then you can also have this. I mean, there's nothing stopping us. In fact, that lower thing, you might just put it right into System.Reflection of metadata. It'll probably be pretty small and be useful versus the bytes that we give you.
don't get me wrong. I don't mind higher level libraries like this, but I think like they should build on I think we've done a pretty good job with the metadata reader, which is very low level library, non-allocating, super efficient and simple. Simple concept-wise because it doesn't do nothing.
so it's simple, but it's not convenient.
Not very convenient to use, and then on top of it you layer kind of convenience APIs.
So that seems like a good place to land, which would be a follow-up item to try to make it so that writing a library like this would have been a little easier with a small forward-only reader, but not to entrench on the sort of shape of this kind of a library.
Because if you have add, you can just reuse.
Yeah, you can
that.
have a method body with iterator, which is
Yeah.
a struct and gives you instruction one by one.
But you see, like what I meant, I didn't mean like just a reader that basically gives you opcode, argument 1, argument 2, because that, like, yes, it's very low level and non-allocating. But then you have things like, is it a branch instruction? Well, you can still have a helper method for the low-level reader to basically say, is it a branch instruction? So it's not just a raw reader of bytes and kind of, it's.
But it will be very similar to metadata reader, basically a bunch of iterators giving you structs with some helpers.
Sure,
Well, it
exactly.
sounds
Yeah.
like it's a potentially good candidate to put in metadata reader, right?
That's what I would do. I would
Yeah,
put that
maybe it should
thing
give a
in
metadata
the-
reader.
Then you have that.
Those
This could
called
be
metadata reader.
Right, but we can
IL is
consider-
metadata.
What's that? Oh,
We need to rename metadata reader.
IL is a form of metadata.
it
Like,
is.
how could you miss it?
All right. So the other thing that I wanted to like just give feedback on is basically just the way the dump methods are wired together. Like I think for the instructions, it's okay because you take a string builder. I would probably make it a text builder. Oh, sorry, a text writer, because it's more generic than a string builder. The other thing I would do is I would probably not have that, and instead have some sort of settings object or whatever, because chances are we want to add one more flag, one more flag, one more flag, one more flag, and then at some point you just run out of methods. And then I would mirror that with the other things here, because on these guys you just basically have, what was it, a dump that basically returns you, where did I see that? Yeah, exactly. So you have that returns a string. Yeah, I think for something where you output something, you should never have that. You should always take the input in and then write to that, because otherwise you have these intermediate strings that you basically create and then just take them and write into a file.
And dump is just for like diagnostics. It's for pretty.
No, that's the actual scenario. You want to get basically ILDASM, right? You want to get text output eventually. So we probably should call it write or write to or something. I think write to is probably a better.
Yeah, that's what I was thinking. So if you go to ILDASM writer, in the dump assembly method, it receives a file or a file writer, where you just write to that file.
I think, yeah, I would probably call it, yeah, I would basically take a text writer, because then you can either write to a file or write to a stream or write to a string builder. They're all like unified with that. And
General question. It seems like in general, this layer, it sits on top of metadata reader, but it seems to treat it as an implementation detail. Like there's no way to go from a method definition to a method to a method spec handle, for instance. And that seemed fine, and it's kind of okay until I saw the token parameter. Like if this is meant to be an abstraction that hides the reflection metadata layer, then should token be there? And if token is there, should we not use entity handle, which is that's the currency of metadata reader? We specifically went away from int because int is not sufficient. I believe there's reasons we went away from. We were using int for tokens, or
we weren't using. You can go from entity handle to its int. There's a method. There's a helper for that, and vice versa.
But there was a reason we went away from that.
We went away from handle to entity handle was a separate. That was a reason.
Gotcha. Okay, that was the.
But I think we could expose either one. There are sort of arguments either way, because there are some things. There are some things that the metadata reader. So it has two namespaces: System.Reflection.Metadata and System.Reflection.Metadata.ECMA335. At the metadata level, there are actually some things that it actually, as low level as it is, it actually does kind of smooth over some things that are very specific to the format. Now, if your purpose is to dump IL, sometimes you do want to drop to that level. So a token is something that, like, a handle is technically slightly more opaque than the token. So if you want this to be, sort of a library that you read the book and then you read, you might want to use tokens, you might want to use handles. I will add that if you have scenarios for going from one to the other, we support that.
But we can't in this API because this only provides the raw token. It treats the metadata reader's implementation detail. There's no way to do the translation.
You have to open them same. Well, you have to open the same assembly with another metadata reader, which is basically, it's not going to cost you that much. Pretty much, and then you could give the token to the metadata reader that you created. And that would decouple them, but I don't know if that's something we want.
Yeah, I'm just saying I don't. It just seemed like everything. It seemed completely separate, plus all the tokens.
Yeah, that's true. Well, I think
it's completely sensible to say that, you would get, let's say, one of those root objects essentially either from the MD reader, similar to how you do other stuff, and then you just like depending on how this library interacts. I think if you are expected anyways to do the translation to get meaningful text output, I would not make the consumer jump through hoops to get there. Like at that point, you have to expose the MD reader in some way or fashion. So either you assume it's being passed in, you make it part of the public API, or you just expose it.
So if you expose, I guess you already have those issues, right? So actually, when do
you dispose today?
It's good. I think it's good in the ILDASM assembly.
What do we need is not disposable. So there's nothing that is disposable in here.
You could always copy on
the constructor.
For what?
So quite honest.
Metadata.
Oh, I see. So you literally do all the work here, you parse the entire assembly, and then you're done immediately. So it's not lazy.
No, I just get an assembly ref from the metadata reader.
But when you call this guy here, by the time this object is
produced, So the assembly is created out with the ILDASM assembly constructor that just get an assembly ref object that is out from the metadata reader namespace, and all of the values in ILDASM assembly are get lazy.
I see.
So they are all lazy.
So then the question, where do you dispose?
Yes.
Where you dispose, I guess, is the question, because you have to dispose the metadata reader.
Unless you copy it always to manage bytes on the heap, and then you. So you don't have to dispose the metadata reader. You have to dispose the P reader, which is the guy that basically has the capabilities of like mapping files from disk. The metadata reader just takes a pointer to metadata, but you need to keep the P reader alive too. Like you need to keep there's this memory thing. So if I give you a stream, for example, and then you just create a P reader, so this would need to become disposable.
So what needs to be disposed? Like if it's
Something, or else you always have to copy the image somewhere to the managed heap, and then it's possible to implement this library without needing.
so when you create this with a stream, you could just say the caller is responsible. Although I don't know if that's the pattern we.
No, it's not just the stream. Like, that's not like. Let's take a note because.
I think fundamentally, probably it's easier design if you take the metadata reader as an input, right? Because then whoever gives it to you is responsible for disposing it, and whatever else it holds on to, right?
So if you go
You
to the
capture your feedback about the dump method and everything.
Yeah.
so if you're going through the create patterns, then that could take metadata reader with it or whatever reader.
But you need actually a P reader
Yeah, you need
because
both.
the IL is not in the metadata.
But the P reader, you get it out from the metadata reader, right?
No, you
As I remember.
create a P reader from the P image, which is either the stream, the file. Right? The P is the bigger thing. It's the whole file. The metadata is a section inside that file. Metadata reader class only knows about the metadata section. But inside the metadata section, there are references to the IL via these RVAs that you have to go back to the P image to say, okay, well, I want these bytes for the IL, so you need the larger image to actually get the instructions.
I think what he was asking is, can you get one from the other?
Yes.
Okay,
Yeah.
so
The other way.
you need to only pass one.
So you
Correct.
pass the P reader and you get the metadata reader out from it.
Correct. Yes, you would need to pass in the P reader.
Yeah.
If you want to make it pass in. But
So that would mean that none of this has to be disposable, but on the other hand, now you can't just simply pass in a stream or a path. It's like another step to create one of these,
and then
right?
we're creating this coupling that we were just discussing. Maybe we didn't want, because I would think that once you want to make this library, you're going to make this library like a publicly dependent on some reflection metadata, then I would tend to say maybe we should start to expose things as handles and so forth to sort of, if that's the world that we live in. But if it seems pretty close to being a thing on its own that's not coupled, and maybe that's what we, and it's unclear actually from the use cases of which one we want.
Would we ever have a different metadata reader that we would like to plug into this?
Not necessarily, but it's just a question of like.
It's just normal layering, right? Like it's just normal layering, right? Like you need does the lower level need to be true or not?
I think I would say the nice thing about the API today is that it's almost universally consistent. The idea is like this is an IL. The fact that the metadata reader is used is completely unknown. The moment I hand you a metadata reader and you give me back objects and I can't go back down to that, if I can't jump between those layers, it's going to be really frustrating. Because like, oh, I'm giving you a metadata reader, you give me a bigger view on it, but you won't let me go back down.
Right. I agree.
That
So
layer.
they're kind of going one direction or the other.
Yeah, it's like if it's an implementation detail, that's completely valid way to do this API. But if I have to show you the underpinnings, you should let me get back down to it.
Yes, I agree with that.
But are there scenarios for that? Because it seems like that might be valuable.
Scenarios could be numerous. I mean, this
Yeah.
gives you strings everywhere, and you might want to sort of like dump some strings, but then like, but also just drop back down to the low level thing and do something that has nothing to do with disassembly. So you might want to sort of walk them in tandem, right?
I mean, we don't have, like if you wanted like the object model that we don't have, then you might kind of do your own and use a combination of these things, right?
Yeah, I mean, filtering is always one simple example where you may want to do that.
But it's certainly,
I think there's enough feedback for like because I mean I don't think that like it's done enough to actually do an exhaustive review, but I mean I think we have enough feedback collected to actually give you some things to think about, and then I think you need to make a decision on like whether it hides the underlying metadata reader, whether it exposes a first-class citizen. There's the lifetime issues in the general design with the how do you expose the visitation versus the actually writing the stuff out, and that should be probably separated somehow. And they will probably result in a fairly different API shape. So you should, I think that's probably fine for now, right? Yep. Plus you run out of time, which is also convenient. All right. Any more questions on that one?
question. So is this just because it's not finished that there's no method ref and type ref, or is it because they're both represented as the same type? And I see only like ILDASM method definition and type. I don't see method reference, for example.
Well, there's this
That's
one.
just because this is in progress, or is that a design to represent them both together?
Well,
Oh, that what's that?
So the type is kind of a type ref.
yeah.
That's type ref part of
They're
it.
different namespaces, right? And I would call them based on, and then type ref doesn't tell you if it's a class or a value type. So only when it occurs in a signature, but which is not type ref.
I know what you mean. Like, if I'm gonna represent like the type refs that the metadata reader gives you as an object.
So when this is the thing. So you have assembly field local, right? But like, and then you have method definition. So is method definition is the. Oh, I see. Otherwise, you would just literally, if you have a ref, you would just have some string inside the IL or something.
Yeah.
Never actually have an object.
Yeah.
Result.
I see.
So the definition is what's defined on the current.
Yeah.
Right, but basically, you're gonna have refs all over the place, but you're just gonna be writing out the string.
String. Yeah.
So do we want to do, so ILDASM as a motor comes with all the tables? I mean, it doesn't have to be part of this project, but like, so you might want some, like, do we have, like, we decode this
Table
like the
decoding?
hierarchy view? Do we want also the table?
That's a good
Just
question.
something for the future, not, just some questions.
All right. Noted. Then let me close this one here. Close this one here. And let me look up this one. All right, so there was one question from the audience, which is the tool that I'm using, and it's an internal tool that we wrote over the years, which is unfortunately not public. We may make it public, or we may not make it public. I don't know yet. So anyway, so the question for this particular thing is like, does anyone of you want to give an overview of what the project is? Here.
Okay. This proposal was initiated by the NI team, and they were porting some apps to .NET Core, and they found a lot of instances of drawing types that were not used in the graphic perspective, but still they were used in a lot of banking applications, etc. So we decided that we need to get the primitive drawing types to .NET Core, and we proposed a API proposal. Like, we saw the other primitives and SharpDX and other gaming libraries, and we came with a proposal on GitHub, and we found that that proposal was not a lot different from what we already have in System.Drawing. So in the end, we just decided to bring the legacy types forward, and this is basically the same types that exist in System.Drawing brought forth in a new contract called System.Drawing.Primitives.
But that's exactly the same. Do they have any?
Exactly the same.
Okay.
This is actually a diff between.
This is not the diff.
Oh, it is. I just did this one here. So basically, that's what I said earlier. So if you do this and this, then you see the full diff between System Drawing Primitives and System Drawing. And I basically just removed types that we added and types we removed. Probably types that we added should be empty. So we remove types. If we ignore that, then that's exactly the shape. And you can see no members being added or removed. So it's literally the same as system drawing.
So do we need 100% compatibility here, or it's just for people to make it easy for them to port code from existing APIs to these APIs?
I don't understand what you.
Basically, would 99% compatibility be good enough for these types, or we need 100% for the scenarios that we hope to enable with those?
Well, I think it would have to be a proper subset.
Yeah, I mean, if we're already 99% compatible, then the additional value of being able to share these types.
But will you be able to share them?
Yeah, if it's a subset,
as
yes.
proposed, yes, you can share these types. They should be portable across .NET Core and .NET Framework.
Meaning we would add a
Yeah, we'd add a
type
facade.
forwarders
Yes.
to.
Yeah.
Okay.
So you can remove members, but you couldn't be able to add. Similar as everything else that type forwards.
So as part of this effort, are we doing type forwarders and
That would be the plan,
basically
yes.
making this to be a portable library like
Yes.
all the others? Okay.
We have infrastructure to do that on.
Yeah.
Okay.
And I mean, there were kind of several decision points about what these types would look like, and it ended up that a couple of them, we ended up back in the place where the drawing types were already, and then we said, well, it's close enough that we should just use
No,
it.
I've been involved in many of these, and now I'm asking kind of like, do we need the last bit and be 100% compatible, or we can do some tweaks? And if the answer is yes, we're gonna provide forwarders and make it really to be a portable library, then yeah, we need to be 100% compatible. It has value.
Yeah, and I think what we think right now is that the forwarders and 100% compatibility are probably more valuable than whatever minor tweaks we could make.
So we also wanted to add color to this, but we couldn't make color 100% compatible, and we have another GitHub issue open to discuss design of color. So yeah, it will be a new type.
What was the issue with color? Why couldn't we make it compatible? Just
So
because we believe the type is more complicated, or?
no, it's just not sufficient. Like the existing color does not have a lot of vector operations on it. It's been treated as a I mean, the existing color is not treated as a vector. Like we don't have scaling or interpolating, or there were some discussions about adding gamma as linear and all that stuff. So we need to like come up with concrete scenarios first for color, and then see where our API is not matching that, and add new features.
So even if it's compatible, are we, I mean, since we need to be 100% compatible, does that mean we can't change, for example, some of the parameter names?
Yeah.
I know we talked earlier about like, this is how they originally looked, but like, we probably wouldn't, if we're doing this over, we probably wouldn't have the parameter names be like PT and SC, or like just have point and size. Are we like able to change that?
Sorry, change what? The name of the
Parameter names on
Like
some of the
might
methods.
not add, or yeah. might
Oh,
not
I
add.
see. So technically, you can when you project, you can change names of parameters because they don't matter, but it can be a source breaking change if people use named arguments.
Yeah.
That's true.
So, I mean, I don't think it's super common that people do that.
These types of probably useless to
It would be
Also
just a-
creates issues for documentation. Suddenly,
Yeah,
kind of MSDN cannot just say yes, it's also portable,
Right.
because then there are differences.
it's only a source breaking change, right?
Yes, it's only a source breaking change. I mean, technically, you have this other limitation that, I mean, if you like the whole scenario is source porting, right? Because you cannot just recompile existing code. You recompile existing code, it's not that the binaries work as they are, right? So the whole scenario is source compact. So in that sense, if you say it's only source breaking, it's like, yeah, but that's the scenario, right? Now that being said, like, how many people actually call these things with named arguments? So is it a likely source breaking change? I would say no. But as Christoph pointed out, there's other problems, and it just seems like more hassle than it's worth.
great.
And it's the most frustrating kind of source breaking change because there's no way for me to write code that works across. If I compile for a couple different places, there's no way.
No, there is. You can use positional arguments.
You just don't use named argument.
You can win by not using it. I can't lose if I don't try.
Well, you just need to not use the feature that you don't have to use.
C-Sharp's done great things.
Invented-
Make sure you don't use it.
Then, so when this meeting is over, this will go on Twitter as overheard.
I can implement features really fast over the compiler if we got this velocity.
That's awesome. But is there any other concern with the types themselves? Because basically we had some discussion before about point F, rectangle F, and I think we concluded that we need both types anyway, and renaming types would be breaking, so that would defeat the purpose. But besides aesthetics, I don't have a problem with that.
So the only thing that we could discuss is that they are now mutable. We could make them immutable by removing some APIs in the portable surface area, but probably it's not worth either.
So
And it's a trade-off.
when we did it with other APIs like vector APIs, right, we basically started with immutable, and we got very strong feedback that people really didn't want them to be immutable. Everybody said this is so annoying if I actually have to initialize them with constructors only. I'm so used to just assign the values, and the feedback was very, very strong on let's make it mutable. These types, you could make them immutable, but first of all, you would lose source compat probably in a large number of cases because people assign to the fields all the time, all the properties. So I'm not convinced it's worth it.
It's probably not worth it, but this creates a bunch of problems, and I don't know if people assign to the fields because other APIs would return copies of these, and then assigning to a field doesn't do anything.
Yes. At least you get compiler warnings, I believe, in that case.
So you get compiler warnings, so then you don't actually do it. You assign the whole instance, a new instance anyway, and therefore.
Yeah, I think it's more common for locals, right? Because you deal with, let's say, you get
Right.
let's take WinForms, right? You get the bounding rect of something, and you just want to basically offset the rectangle to a location. It's very easy if you just get the rect, and you can say rect dot, what is the thing called? Origin or top, and just assign it directly, right? It's just so much more clear what the code does, as opposed to you rectangle and then passing in the old values. You kind of have to what's the difference between what I have and what's there? It's harder to read. That was basically the argument that people had.
It's cheaper. Sometimes this stuff is perfect sensitive. You're having a bunch of moving objects on the screen, and adjusting just top left coordinate is much cheaper than replacing the whole bounding box for every object.
I'm saying that in a lot of cases you have to replace anyway, because you can mutate the local value, but then to actually assign it to the bounding box, as you said, you need to make a copy, and you're making a copy anyway, because they are structured, right?
I'll have a list of objects and I'll be changing their positions 60 times per second for all of my boxes.
No, to be fair, with system drawing, I think you don't get 60 frames a second in any reasonable screen real estate. But
So this is not in the system drawing.
I'm just saying. I think the per film is probably not.
Currently, every place which deals with graphics redefines this. So
Yes.
like XNA will have those, Monogame will have those. They'll all be slightly incompatible. That's annoying.
And that's the other thing, right? Interop is a lot easier, and
Anyway, I'm fine for many reasons. The only thing that I was saying is for a lot of APIs, mutable APIs totally make sense.
I moved from
Because the way that they are used,
several times, but now I
people
think
hope that they will get efficiency, but they don't because the other APIs that use those make copies anyway. So, but anyway,
sure. Are you fine with the name, by the way? System.Drawing.Primitives. Yeah, you're already fine with the name?
Are there any precedents for this and where we're yanking out smaller subset VLLs? Is there another name precedents?
Yeah, primitives. Like it happens when I think reflection has primitives. There's some others that have that. IO has primitives, I believe. Like it's pretty common. Done this many times.
Model, right?
So are there
Well,
any,
that thing
That's
is
been there
actually
for a
not
while.
primitives, and it's actually not that small of a subset. So
We use the name.
just yeah, we use the name.
are there any other like types? Are these like the most used 6 that we picked? Are there like
Oh, that's a
other
good
ones that
question.
weren't, like,
Let's look at the
as
remove
used?
types for a second. I think the answer is, if you look at the ones, there's a whole bunch of stuff in there. I think the ones we picked were basically all the ones that have to do with, drawing independent.
And the other ones are like drawing APIs, and
They're
like image and bitmap and
Yeah,
stuff are
just-
used
that's like
super commonly, but
Are there any other like structs that are like this?
Yeah, so the only other ones that we have are like either matrix is probably not even that. Matrix, Marshall by ref object. It doesn't even capture how sad that is.
it's a class. Oh my.
Alright, that's clearly not a primitive. I think the other ones are, I think, also more Windows specific. And then printing, I think there's a whole bunch of stuff in there.
So can you show again the top namespace system?
Yeah, the very top.
Because I thought there were some like, what was it, size? Can you scroll a bit to S? They were like helpers. Like size converter. What does it do?
That one is basically the whole type converter magic grid and
okay.
property grid.
Yeah,
You do
we
that.
don't want that.
I don't think we do.
Position converters for like everything in here.
They all have to work in a property creator.
So yeah.
What is size?
Properties for WinForms.
Yeah. All right. And so I assume what I was to say is, so we would build a NuGet package essentially that would have the facade in that supports 4.5 or higher. I think this guy only depends on system runtime, I believe, right? Yeah. So it's as primitive as it gets. Cool. Right.
Wow, that was a quick
It's a pure subset, so what? There's not much to review.
Let's review system string now.
Right, this is when I end the recording.
You missed the no silliness part.